Hello, class. Mr. Bean here. AP Physics, Unit 1 Motion, Free Fall Presentation with Problems. This will be video number 5. I'll go ahead and go to present mode. And this is a kind of a Google slide, so I will not read the slides to you. I'll only make comments when something is important. And here I would note, for the purposes of the AP exam, it is acceptable to estimate g as 10 meters per second squared to simplify calculations. You may want to write down notes as needed. And then here, if acceleration and velocity are in the same direction, it speeds up. If they point in opposite directions, the object slows down. Problem check. Problem 1 check. Work and answer the question. Problem check 2. How far will a brick starting from rest fall freely in 3 seconds? And here is the solution. It should be 44 meters. Problem check 3. A ball dropped from rest falls freely until it hits the ground with a speed of 20 meters per second. The time during which the ball is in a free fall is approximately B, 2 seconds. In summary, here's a table 4.3 here showing total distance moved by a freely falling object dropped from rest. At the end of each second, at the end of 1 second, it has fallen 5 meters. At the end of 2 seconds, it's fallen 2 meters. At the end of 3 seconds, it has dropped 45 meters altogether. Clearly, it is nonlinear. For each second, the object falls a greater distance than it did in the previous second. These distances form a mathematical pattern. At the end of time t, the object has fallen a distance d equal to 1/2 times g, acceleration due to gravity, times squared. So it is quadratic in nature. Here's a free fall distance of objects again. This time we'll go ahead and graph it. So the distance versus time, this should be familiar to us by using the Pascal motion cards. So it is parabolic. And here's another table here. If we were to plot the instantaneous speed at each second, we would get a straight line, a linear, a straight line like this. And this line right here, the acceleration would be 9.8. So the slope of this is the acceleration. Objects launched upward. So examining the motion of an object launched vertically upward is done in much the same way you examine the motion of an object falling from rest. The major difference is that you have to look at 2 segments of motion instead of 1, both up and down. So here's an example here at 0 seconds. The ball is given initial velocity of 30 meters per second upward. So as it moves at this location here at 1 second, let's say it drops to 20 meters per second. And at 2 seconds, it's now 10 meters per second. Then at the end of 3 seconds, the velocity is 0 at the very top for a brief moment. Then at 4 seconds, it begins to pick up speed. Notice here, at At 2 seconds and 4 seconds, velocity equals 10 meters per second. So when solving for a quadratic equation for time, you get two answers, one for up and one going down. At 1 second and 5 seconds, the speed is 20 meters per second. So speed going up is equal to speed going down at the same corresponding points. Then at the location at which you launched it from, it was 30 meters per second at 0 seconds. At 6 seconds, it is also 30 meters per second. That is the speed. However, the magnitude is the same, 30 meters per second, but the direction is downward here and upward here. And then finally, at 7 seconds, the ball is at 40 meters per second down here. Okay, and look at the symmetry. So over here, whether the ball goes up or down, G is always acting downward. The sign of the acceleration depends on the direction you declared as positive. But in all cases, the direction of acceleration due to gravity is down, towards the center of the Earth. My suggestion would be up is positive and down is negative. Problem check number 4. Zero meters per second. Trick of the trade to solving freefall problems involves symmetry. Problem check number 5. Problem check number 6. Problem check number 7. Problem check number 8. Problem check 9. There's the answer, and we are at the end.